Yeah, I hope it's already showing because there's this commercial thing going on as well. But yeah. If it's already live, then hello, my name is Armin. I'm a product specialist.
First mistake. Right. First mistake.
So I'm a product specialist with Notch, and today I have a colleague with me, Ryan.
Hello. My name is Ryan.
So the way we're gonna run this is I'm gonna build something, and Ryan will take care of the chat. And if you guys have a question, he's there to answer. And if the question is big and intricate, we'll try to replicate it or address it in the setup. We're gonna split this whole stream into two parts. So basically, we're gonna pace ourselves through this list here. So we're gonna talk about cloners and its effectors, then we're gonna check out clone to mesh, then clone to volume, clone to spline, clone to image, clone to particles, clone to procedurals, clone to transform array. We should hopefully cover that in half an hour or so. And then we're gonna move on to a more complex setup where we use quite a few of these things together and we build a setup or setting similar to this. Right. So before we get started, I think it's worth mentioning that a good source of information is notch.1 page with Academy course. So the basics of the cloner is already available there, and there's quite a bit more. So if you have a chance, do check it out. All right, so cloner. Let's grab the node. So now we have a cloner node in the scene. For cloner to work, we need to feed in some kind of a shape to it. So shape 3D. I'm gonna set it to the rounded box. So by default, not much is happening, but as soon as we offset some values in cloner, we start to see it taking effect. So by default, it's set to iterative cloning. And there's three modes we can choose from. So iterative cloning, 3D grid, and radial. And radial basically just builds a radial setup of clones. So I think I'm gonna start up talking a little bit more about 3D grid. So again, we have a cloner node in the scene. It's piped with the shape 3D set to rounded box, and in cloner we're gonna set it to 3D grid. Now this looks a little bit dull because it's so uniformly lit. So I think one of the first things we want to do, maybe make this a little bit smaller, add a couple of more cloners and light it up. So in the cloner node, I'm gonna make sure to add more clones. So as you see, as soon as I took 3D grid, this whole panel became available for me, so it lit up. So here in the first three passes, I'm gonna put in 5 by 5 by 5. So basically now we have a cube, which is in iterations of 5. And that's quite all right. So I think now we can add a bit of lighting. In fact, yeah, let's just make it smaller. There we go. We're gonna use voxel cone lighting for this. I really like voxel cone lighting because it's very decently looking lighting with little effort, and it's uniformly smooth. Ryan, do you want to add something about voxel cone lighting?
Yeah, voxel cone lighting, it's sort of a really easy way to make your lighting look really nice. You can get really nice global illumination, some reflections as well can be done through this node. Ambient occlusion is what I expect you're going to be going through.
Yeah, exactly. And as you see, once we plug it in, not much is really happening because voxel cone lighting requires an extra node, which is bounding box. So basically all lighting is happening in a restricted area, which is dictated by a set very bounding box. So if I make it bigger, as you see now, we are exceeding this bounding box in our cloner. Now again, nothing is happening because there's several options that we have to enable. So I'm going to click on a root node. I'm going to tick on deferred rendering, high dynamic range, and anti-aliasing for a good measure. So there we go. Now we see some lighting happening. Again, if I reduce the bounding box, I see how it affects the overall voxel cone behavior. Right, so By default, there's several things that we can do with the 3D grid. We can set it to spherical or cylindrical mode. I'm going to keep it in cubic. We can make sure that it's either filled or empty. So basically whether there is information inside or not. And the whole fun part of it comes when we start to use effectors. So if I now go to the list and expand the effectors list, I see that there's quite a few to choose from. So I think I'm going to start with the plane effector. So plane effector comes in to the graph hashed out. That is because it requires to be plugged in somewhere. So very cloner node has an input for effectors. And as I pipe it in, I see a slight change. So I'm unhooking it, by the way, by holding Control Shift. And that is because there is a default value given on a position Y. I'm going to reset it to 0, and I'm going to talk about different panels here. So if I pan out a little bit, I see that there's this sphere. So this sphere is actually fall off. Fall off is responsible for the area of influence. So we can manipulate the position of the fall off in 3D space, and we can manipulate its behavior. So in this case, now it has no behavior whatsoever, but I'm gonna tick on uniform scale and I'm gonna make it smaller. And as I do, I see that it affects the whole setup here. So instead of this plane effector affecting the whole thing, I'm gonna make the fall off smaller. And I'm just gonna position it a little bit to the side, for instance. So I actually want the fall off to work much harder on that specific area, so I'm gonna increase the inner fall off. There we go, we have a little controller now for the scale. Well, let's add, for instance, one more vector. Maybe random. So randomize effector. I'm gonna plug it into the same input, and just like the previous one, it has two sets of parameters: the positional values and manipulation values. So I'm just gonna make sure that we have it all twisted. I'm gonna make the fall off smaller. I'm gonna increase inner fall off. Right, so this is starting to get somewhere. I could offset them and control them separately, or I could add a little controller to control them both at once. So by the ways of notch logics, usually you would have to parent things to work. And as you see, these ones has parenting option as well, but they are not parented and they're still running. Well, let's take a look to the option that we can apply here to make those parentings run. So from the geometry, I'm going to choose a null. Now, null is just a positional value that we can tweak and alter. So if we take a null and we hook it to the parents of those two effectors, now effectively this null is controlling both of them. So we just made a little controller for ourselves to drive both of them at once. Let's give a little bit of shading to this. So from the list of effectors, we can grab a, say, color ramp effector and plug it in. And for color ramp effector to work, we need one more node, and that is the very color ramp. So I'm going to grab that. It has an input, the first one here. And now I have to give number of colors that I want to use. So for this instance, I'm going to use 4, and I'm going to give a bit of gradient. For instance, maybe a couple of orange colors and a slight of blue. And as I see, yeah, it's already taken effect. And we can actually address how should it apply those colors. So by default, it's working on position X. So my usual thing to go to is either random or fractals. I'm just going to leave it at random. So that's regular cloner. Now we are using several effectors, and we are not restricted to how many we want to use, and we can actually use several shapes to output from it. So in this case, I'm making a copy of this rounded box, and I'm going to set it to, for instance, a sphere. Now, as you see, nothing happened, and that is because the box is actually bigger than the sphere by default. So if I was to choose iterate or random, then all of them shows up. I'm going to leave it at iterate. So maybe one more thing to mention that is handy is the fact that we can clone a cloner. So I'm just gonna grab one more. And I'm gonna unhook this cloner from the root, so Control-Shift, and pipe this one through. So by default it's set to iterative, so if I start to drag it around, you see all of a sudden we have iterations going one or the other direction. We could easily set it to radial, for instance. And then we have radial copies of the cloner. Right, so I'm just gonna take this one off and I'm gonna leave it at that. So this is one of the most primitive cloner, or the basic cloner. There is a whole list of other cloners available. So let's take a look to a clone to mesh. Now, clone to mesh could clone to a primitive shape that we have in Notch, or we could actually use any shape that we desire to import from other packages or from online websites. So I'm just gonna make a new layer. Insert layer, I'm gonna call this mesh. So my go-to place for motion-based FBX models, for instance, is mixamo.com. So if you have an Adobe subscription, you have full access to all its features. So you can choose the characters that you want to download, and they have quite a few available. And you can choose animations that you want. You can, of course, choose to upload your own character. The only thing you need is a OBJ or FBX-based file in a static T position. You put the points for the joints, and it makes it all for you by default. So very conveniently, I have this looking around guy already downloaded. So I'm just gonna import it to my assets. I'm gonna wait for a moment for it to load up. Huh.
Patience, Armin.
Yeah, not the trait that I'm rich with. Oh, there we go. So now I'm just gonna drag it into the scene. Again, I need to connect it to the root so that it would start rendering. And I see this giant foot here, so it's way, way too big. So with the unified scaler, I'm just gonna make it smaller. There we go. So, by the way, I'm using ERTY for manipulating different modes. So now I just want to turn it around, and I want to take a closer look to this model. So even if I've chosen animations for it, they came in as a static object, and that is because Notch supports animation sets, so you can easily preload it with several. So in this case, the first one is static T, and the second one is the one we've chosen, where the guy's a little bit lost and looking around. Right, maybe one of the first things we should do is add some lighting. So I'm gonna go again for the voxel cone lighting. I'm pressing Ctrl R for red to connect it to the root. So again, Ctrl R. It does need a bounding box. So I'm gonna pipe it into the second input of the voxel cone lighting. And in the root node, I'm gonna enable the deferred rendering, high dynamic range, and anti-aliasing. So now all I have to do is make sure that my bounding box is bigger than the object that I'm bounding. Cool. So we already did that several times. I'd say that it's probably wise to make a preset out of this so that as we move further, we don't have to recreate it time and time again. And we can do that by marking both of the nodes, pressing Ctrl G to group it. And then if we right click on the group, we can choose to send to bin. All of this is set up. So let's call it light. And let's call this voxel light. So as I hit OK, I see already that it appears in my bin list. Voxel light, light. And that actually can be called out from the view menu, bins. So if I was to delete this and just drag in the lights, the whole rig is available for me. And I can press Ctrl-Shift-G to ungroup it because I don't really need that group there. All right, so let's move on to the cloner. So as you see, there's a whole list of cloners available. And as we've spoken, we're gonna go for clone to mesh. I'm gonna grab that, connect it to the root. As you see, it's still hashed out red. And that is because it needs a source object. And we want to use this very guy as a source object. So if I press on this little triangle here in the bottom, it expands the whole bin of the imported 3D mesh. So this 3D mesh has a bit of information. So the whole skeletal structure and 2 OBJ files. So one is the surface and the other one is the joints. And I'm pressing Ctrl 1 to turn it on and off. So I'm gonna turn off the joints. I actually don't need it at all. And I'm just gonna refer to surface. So this pink node, I'm gonna connect to the first input of the clone to mesh here in the bottom. And now, just like previously, I will need some kind of a shape to output. So shape 3D will do just fine. So I connected it. I'm gonna set it to a rounded box. And I see that things are happening, but maybe not exactly as I expected. Why? Well, for starters, these boxes are way too big. So I'm just gonna make it smaller. And if I check the mode of how it's applied, it's going for the vertex. So I actually would like it to spread over the surface. This is becoming a little bit better. Well, there's quite a few to choose from, and depending on your task or your project, you probably will choose one or the other. For this very instance, I'm gonna go for spread over surface. They're still too big, so I think I can make it smaller just by making the object smaller, or I can actually do that via clone scale. So this time I'm gonna do it by the clone scale. And I think we can afford to have more of clones, so I'm gonna make it 200. Cool, so I don't really need to see the actual shape of this fella. So what I can do, I can go to the imported 3D scene, and under the visibility I can set it to 0. And all of a sudden then in the scene we have only the clones. Brilliant. We spoke about effectors. I think randomized effector would be quite nice here. So as you see, the second input now is the effectors. So that's where we plug it in exactly. By default, it has an offset on a position Y in an effector transform. So I'm gonna just flesh it out, and I'm gonna offset some parameters here. In fact, I want to have it sort of randomly scaled. There we are. And I think this guy would benefit of having a floor to stand on. So I'm gonna grab a shape 3D. By default is sphere, so I'm gonna set it to a circle and make it a little bit bigger. So it's a little bit edgy, this circle, and that's because the subdivisions is quite low as a default. We can always bump it up, so let's say 90 by 90. Good way to save resources before you bump up the subdivisions, it's turning on tessellation. So I'm gonna do that for the good measure as well. There we are. Now we have clone to mesh. Of course, we can further apply different effectors to make this more interesting and more elaborate, or we can have several shapes as a output. So let's say for this one, I'm just gonna choose capsule. And I'm gonna make sure that the spawn mode would be, iterate or random. Now random would kick in if we have more than 2 shapes. There is not much randomization to be achieved with 2 shapes. But anyways, here we have this square pill guy. He's just as lost as he was before, but I think we can leave him. I'm working on my dad jokes. I'm gonna move on and I'm gonna check out what else do we have in the list. Clone to volume. Now, this, in a rig sense, is very similar to clone to mesh. It's just it looks a little bit different. So if there's any, how is this called, Minecraft fans, you might find it quite interesting. So, but instead of making this all again, I'm just gonna make a copy of this layer. So Ctrl C and Ctrl V. And it came in as a mesh 2. So I'm gonna solo it out and I'm gonna hit F5 to access settings. So I'm gonna call it volume. So now I have a direct copy of the previous setting, and either I can unhook everything and change it with a clone to volume node, or I can press right key and go for replace node with, find the cloner or cloning and just choose clone to volume. And as I do, I see things changing. Now, the default settings here for us are probably not that applicable, so let's just see what tweaks can we make to make this smoother. So I think I'm gonna start by ticking off scale clones by voxel size. I don't really need that because it just misshapes those. So I want them to keep the original shape. And randomize effector is not helping us here, so I'm just gonna tick that off. All right, so here we go. We have a Minecraft guy, still as lost as he was. I think we can reduce this clone scale, and maybe we can actually add a bit more, like 40 by 40 by 40. I think you get the gist of where is this going. Again, we can put several shapes and put the effectors to make it run. But the very essence of the rig is just like rigging clone to mesh. So you have an imported 3D scene, for instance. You make sure to grab a 3D object and then you pipe it into the first input source object. So that's true to quite a few things in Cloner system. Right, let's move on to a new setting. Let's check out clone to spline. Now, this one we're gonna spend a minute more. It's just more to talk about, basically. So I'm gonna insert layer, and I'm gonna call this spline. Now, I know for a fact that I will need deferred rendering. Anti-aliasing wouldn't hurt, and high dynamic range, well, that's just a good thing to have. Okay, let's open it up. So I'm gonna start up probably with just adding a light system, even though we aren't going to see much, but since we have the preset there already, I'll just pipe it in. And I'm going to unhook it from the group, so Ctrl-Shift-G. So now we have lighting. Let's add a spline. Probably that's a reasonable place to start. So I'm typing in spline and I'm grabbing a spline node. I will connect it to the root, and as you see, nothing happens. Well, that is because we have no spline with it yet. We have to make the spline. There's several ways we can do that. We can either build spline in Notch, or we can import it from Cinema 4D and other packages. Yeah, but let's build one here. So the way we do splines is we use nulls. So nulls becomes points that can be connected and would become that very spline. So I'm gonna grab a null and hook it to the first input here, spline nodes. And as I make a copy, Ctrl-C, Ctrl-V, I start to see that something is happening. Now for this to be more visible, I'm just gonna offset one of the nulls. I'm gonna pivot it a little bit. I think for the good measure, we should have at least 4 of these points to make a decent spline. So I'm basically just offsetting it in a 3D space. Now we have 3 points. Let's add one more. 4th point. And let's place it a little bit out as well. Let's offset it. Now I'm offsetting it because I just don't like the way it's pivoted. Like, I don't know if it's really visible, but I'm certain that it's going the opposite direction that I'm intending it to go. So I'm just straight away offsetting it. Cool, so now we have a spline, but it's not connected. So we can take care of that in the very spline node if we just stick on looping. Now we have this beautiful looping spline. What a crazy, awesome art this is. So for us to take advantage of it, we need a clone to spline node. So I'm gonna grab that from the list. As you see, it comes in hashed out red. Even if I hook it to the root, it's still hashed out red. Now that is because it requires that extra information. So just like in 2 previous settings where we needed an object, now we need a spline. And spline goes to the first source here. So source spline. There we go. True to any cloner, we need some kind of a shape to output, so shape 3D is a way to go. Now this is way too many clones. So straight away I'm gonna go to the clone to spline and I'm gonna reduce numbers from 100 to maybe 50. Still reasonably too many. In fact, they are too big, so I'm gonna go and I'll go ahead and make the scale smaller. This looks more reasonable, and I'm certain that we are exceeding the bounds of bounding box. Indeed we are. So I'm gonna grab the whole cloner and just gonna reposition it. Or perhaps it's a better choice to reposition the bounding box, actually.
Yeah, scaling up and moving the bounding box is usually
more trusted, no?
Yeah.
Oh, by the way, if you don't see the handles in your viewport, make sure that you're not in a playback. Like if it's in a playback, it hides all of them just for the clarity or readability of the graph. But if you stop the playback, it's there available for you. Now, I made sure that my bounding boxes would be visible even in the playback, and I did that by view, show bounding boxes while playing. I think it's just handy. So if I hover over a node or click on a node, still see what it does. So Ryan could look at this and say like, Armin, super interesting, super amazing, but it's absolutely static. Ryan, you are right. This is absolutely static, but since
it is absolutely static, and
it is absolutely static. Since we built this in Notch, we can use continuous or math modifiers to change the positions of these nulls. They don't have to be static. We can update them dynamically. So let's do that. Let's update several of them dynamically. I'm gonna grab a math modifier. Now, math modifier just splits two distances or two pieces of information. So it's A and B, and it's sort of oscillating between A and B in this sine wave, and there's great many to choose from. Basically different interpolations of that very wave. So I'm gonna leave it at the default sine. And what I want to do, I want this null to go up and down on the position Y value. So I'm gonna double click and expand the hookup list. So basically all of these are available for me to be used with modifiers. So I'm gonna plug it into position Y. Brilliant. Too fast though, definitely too fast. So I'm gonna reduce the speed. I think I'm gonna use the very same modifier to change, for instance, heading. Why not? There we go. Well, for the heading it's probably not showing much because it needs more value. So I am going to untick it. I unticked the wrong one. Greatness. But I'm gonna use the same modifier to move the other points. So maybe this one should change its position Z values. Right, so those two are moving now. Let's grab a third one and let's apply it to the position X. Nice. So, well, let's not leave this one as a lonely ranger. Let's just add something for him as well. There we go. Now we have a dynamic spline. We could easily grab one more math modifier, and I really would like to address the rotations. I think that would be just fun. So for this instance, let's see which one would be a good one. Yeah, maybe heading of this null. So I'm gonna apply this to the heading of this null. I'm gonna bump up the scale even more. As you notice, we have I think it's called arbitrary or default setting from 0 to 1, but we can easily exceed that either by typing in specific numeric values in the box here, or just holding Alt and dragging. And as we do that, we just exceed the default setting. Now this is a bit crazy, so I'm gonna make it into a little bit more reasonable 100. So now we have a couple of modifiers. And just to finish up with modifiers, I'm gonna mention that we can have a controller for both to be controlled at once. So if we grab an envelope modifier, that's like a virtual slider on a, for instance, MIDI controller or a light desk. So if we double tick on the modifier, we can plug this envelope either to scale or speed. So for this example, I'm gonna plug this one to speed. And as I do, now I have control over the speed. So I'm basically changing one value, but it's affecting both. This does not make it a better design, but it becomes a little bit more flexible. Right, so before we move on, there's a couple of other things to mention. I think they are very uniform. So I'm gonna go for the randomize effector. So randomize effector goes to the second input, and as you see, if I click on it, all of a sudden a plausible hookup point lights up. So this is definitely something that would work. So I'm gonna hook it in there. Again, it has a default value of position Y being offset. I don't want that. I want uniform scale, and I want it to become bigger, because more is more. Right, so let's say this cell is somewhat the design that we're going for. Now, what we don't want to see is this grid. So I'm gonna press Alt-G to hide the grid, but I see that I still have the spline being rendered. So what I can do, I can go to Spline and untick Show Spline. And then Ryan can go like, Armin, this is brilliant. Can this all be a particle emitter? And my answer to this would be yes, but there's one little gotcha. There's one node required to send all of the cloner, or for that matter, any cloner, to particle system. So before we unveil that specific magical node, let's build a very little, well, hello there. How do I get rid of you?
What have you done?
I messed about as always. Right.
Oh, man.
Let's go for the particle system. Now we're gonna use only a couple of nodes. Basically, to run a particle system in Notch, you need 3 mandatory and 1 optional node, which is particle root that defines our allowance of particles, emitter that defines how does this system look, renderer that defines how the sprite looks, and effector that just gives motion to it. So I'm gonna grab particle root, and as particles are quite a vast subject, again, it has its own particle root. So naturally, I would use a mesh emitter to pipe in all of this system. So I'm gonna go for mesh emitter. And we need to see something popping out. So we need something as a sprite. So point renderer will work just great. And let's just add a default motion to it. So perhaps turbulence. I appreciate you clicking this with me. If you are and seeing nothing, we will see something very soon. So a natural course of things would be to grab a cloner output and just pipe it into the mesh emitter. Well, guess what? Not working. Why? Because these two systems need an intermediate node to make sure that they can communicate properly. There's probably more scientific and proper explanation, and I'm sure Ryan can provide us with one.
Well, essentially, the shape 3D, when it's being used by the clone to mesh, it's instancing that mesh around the spline in this case. But when you actually start trying to pipe that into a mesh emitter, the mesh emitter is just going to use that singular shape. It's not going to actually do it from the whole clone system. So for that, we have a combined geometry, which will combine the geometry from that clone system so that it can actually be used by a mesh emitter or a field mesh emitter, or, you know, we'll go through a lot.
Actually, it could be any, like if you want to have 3-4 different meshes to be treated as one emitter, that's just the way to go. So I'm going to grab a combined geometry, I'm going to connect it to the root, and I need to pipe in this shape 3D to the first input, the geometry source. As I do, now I can take this one, you see this one lights up, the first input here, object node. Now I can connect those two systems together, and ta-da! We have a blob weirdness-based particle system. And again, the way it's being driven is by this turbulence. So if I just disable it, then the whole motion is coming just from the nulls moving up and down. But I'm quite a bit fan of turbulence, I'm just gonna leave it there. Now our sprite is super boring. By default it's set to a unified scale, the quad, but we're just gonna leave it at that. I think you get the idea, and there's way more to cover, so let's just move on. Right, so another one, clone to image. Right, so I am going to make a new layer again. I'm gonna call this image. Again, deferred rendering is a must, anti-aliasing, high dynamic range, because of course. Cool, and you probably noticed that there's a tendency of grabbing a node from this list. So in this case, it's going to be clone to image, the very first one. And there's two things needed. It's information on what should be driving it. Well, for the mesh one is 3D object. For the spline, it's the very spline. In this case, we need an image. So I'm gonna run to my desktop, and I have one video available for me. So I'm gonna grab a video, and I'm not gonna catch it properly. There we go. So now I'm just grabbing this video from the list. It's sort of just linked up. And it's a couple of guys having fun on stage playing guitar. Greatness. What I want to do is to take this video and pipe it to the clone to image system. Now, before I do that, there's one more node needed. Again, just like in any other cloner setup, we need a 3D shape to output. And since we have the third rendering on, but no lighting, we see nothing on the screen. And we can fix that by adding a very same preset we just did. So voxel lighting light. Right, that's there. Ctrl-Shift-G to ungroup. And now we see, I'm just gonna make sure that I have a bounding box exceeding it. Now we have this beautiful white quad consisting of shape 3Ds, the very shape 3Ds we piped in. And that's the premises of how clone to image works. So just like image plane would, by default, it just outputs a white quad. Just in this case, this white quad consists of clones, and those clones are defined here, like 64 by 64 is default. Right, so let's grab this video and let's pipe it into the clone to image. It's gonna go to the first input. I'm gonna press Alt-G to get rid of the grid, we just don't need that. Brilliant, so now it's working. There are some issues with it though. Our video by default is 16 by 9 and this is just a square. So let's address that. On the clone to image, on the scale X, either we could go to some calculation system and just predict how we should set this up to be more 16 by 9er, or we can just write a small formula like 16 divided by 9 and get it done, or get that done for us. So since numbers on X and Y axis are equal, all our clones become a little bit squashed. So I'm gonna change these values to 128 and 72. Which is in many respects sort of corresponding to the scale of half HD or small HD. Anyways, it just grants us a proper sprite or proper 3D shape. That is not correct to call it a sprite. Absolutely not correct. Do you concur, Ryan?
Yeah, it's not a sprite. We're dealing with geometry.
If you were given a chance to choose someone to voice over Notch tutorials, for instance, who would be your top 3 picks? I'd say Morgan Freeman. Morgan Freeman is the first one, and David Attenborough.
If you mean David Attenborough, or you can't rule out H. John Benjamin, Bob's Burgers.
What was the name of the? What was the name? Have you seen Catch Me If You Can with DiCaprio? That he had a father.
He had a father. I haven't seen that film in a long time.
There's this distinguished.
Walking.
This is really good. Yeah, man, this would be amazing. Anyways, we're sidetracked. So, what's so fun about this?
Herzog is a great shout in the chat.
There we go. Yes, indeed. Yes, I am dreading to pronounce the surname incorrectly. Herzog. I'm
sure I'm pronouncing it worse.
Yeah. Well, okay. Let's come back to this. So, what fun or what crazy can we do with this? Well, basically we can come back to clone to image node, and there are several tweaks that we can make. For instance, we have brightness threshold. We can increase that, so all of a sudden we hide the darkest areas. We can go for clone by scale, or clone scale by brightness. So all of a sudden the brightest ones are the biggest ones. And one of my favorites is clone offset by brightness. So we just extrude it in 3D space. Yay! No decent setting is ever accomplished without a post effect glow. Just gonna apply that. Just gonna leave it there. Yes, now it's glowing. Customer is happy, you are happy, we can move on. Oh, I'm just gonna add a effector just for the good measure, just to show that these are applicable here as well. So for instance, turbulence. All right, this is grooving around. I'm just gonna reduce the animation rate. Cool. What else do we have in the list? Spline image particles, clone to particles. Right. So we spoke a tiniest bit about particles already. Let's come back to that. By the way, this file will be available for you guys to download once we're done, just so you know if I'm going too fast. That shouldn't be an issue, because you will get that need be. Okay, so let's start by adding a clone to particles node. Now, it's not going to do much for us just yet, because we need a particle system. So the next thing I'm going to do, I'm going to address that. So yet again, just like before, we need a particle root. And we need some kind of an emitter. So primitive emitter will do us fine. And as you see, primitive emitter has this sphere shape. We can actually alter it and change it to any other. There's quite a few available. So instead of having external 3D object driving the shape, we can just use that one. I'm going to leave it at sphere. Cool. So I think we should add some kind of a behavior. So turbulence. Turbulence should work. And now we need to connect those two. So clone to particles has particle node input. So I'm going to pipe in particle root straight there. Now, for us to see something, we need a couple of more nodes. So the very shape 3D or any 3D object to output from clone to particles, just like any other cloner setup. And we need some kind of a lighting. So I'm just going to refer to that same setup we did before. So I'm going to take off the grouping and aha! What's going on? It's still hashed out red. Is the deferred rendering on? Absolutely not. Let's put it on. Still nothing on the screen. Well, let's start simulating. And as we do, it starts to spawn particles. I'm gonna reset the playhead. I'm hitting home. Since it's particles, it needs to get born, so to say. So in the first frame, you might not see anything unless you set in a pre-roll. Pre-roll is working in seconds. So let's set 5-second pre-roll. Okay, maybe with cloners, that's not that. Well, yeah, it is there. Boom. This is a horrible setting because those particles are just way too big. So I'm just gonna make it smaller. And I'd suppose they could have a bit more size randomness, for instance, and there could be more of them. So in primitive emitter, we have a setting for the max particle count, but that's being disregarded because we're rendering to cloner. And in cloner, we have five particles. That is just not much. So I'm gonna bump it up to 50 and expect the best. There we go. So now if I set a bit more of randomness, where it is, size randomness, there we are. Well, voila. Now we have clone to particles. Actually, we could go for inception. We could grab another particle system, combine geometry, and send this to become a mesh emitter. That would be something. Well, let's move on. That would be just a waste of time. But that's possible as well, need be. Right, so this is clone to particles. Again, several of these things that we're talking about now, we're gonna come back when we're making this bit more complex setup. But let's move on.
And a question from chat. What's our catchphrase?
Notchella.
Notchella.
Notchella. Notchella. If there was ever a party where people who uses notch comes together to have a beer, or any other adult beverage, Notchella. And we should be referred to Notchella, and that should be our catchphrase, Notchella. Wouldn't you agree?
I mean, I wanted to argue, but that was an extremely well worded and forceful argument.
I might have anticipated such question, and I might have rehearsed it. I just might have.
Are those notes below you? Are those a full prepared script?
Well, I just don't want to confirm that. That would just ruin the whole. You ruined the moment, mate. All right, let's move on. Clone to procedurals. Right, I'm making a new layer. Procedurals. And let's take a look to that. So just like any other bigger system in Notch, procedurals would have its own root. So I'm gonna start out by building procedurals. So I'm gonna add a procedural root. I am going to add a mesh, procedural meshing. So procedural meshing in this instance is sort of like a renderer. It just describes the procedural system on what should it do, how should it render, because it could be volume, it could be meshing, it could be various things. Now we have those two nodes here, but we have absolutely no information what this meshing should do. So we need either a external 3D object or a primitive available for us in the system. So under the generators, there's 3D object. I'm gonna pull that in. And as I add that, nothing is visible because... Oh yeah, that's because we need a 3D primitive. Silly me. There we are. So 3D object would be a node that has an input for external information, just like we've used with the, say, mesh or volume generator. Right, so now we have these three nodes. Procedural meshing, just like voxel cone lighting, has a bounding area. And all we are doing with procedurals can live, exist, and go nuts only in that specific area, only in those bounds. Now, as you see, we have 3D primitive and we have these black dots here. Now, what do they mean? They just mean that this 3D shape is bumping the walls of the procedural meshing. I'm gonna make it excessively big. See now, this 3D primitive is way too big because procedural meshing's bound box is way smaller. So I'm gonna make this 3D primitive smaller too. So now it's living happily in the center of it. In fact, I'm gonna offset it a little bit to the side and I'm gonna make a copy of it. I'm gonna pipe it to procedural root and I'm gonna bump it to the side. And I'm gonna make it smaller. Brilliant. I can see nothing. We need a lighting. So I'm gonna grab the same lighting rig we did, pipe it in, not working, deferred rendering, yes indeed, anti-aliasing, done. So this is sort of working, but it has this horrible tear. My idea here is to make those two 3D primitives look and behave as if they're one, and we can address that with any 3D primitive. Mind you, there's a few, like it could easily be a box, for instance. So I can make those seamlessly coincide with a CSG mode. Ryan, CSG, what does that sound for? CSG.
CSG. Oh, I can't remember. Oh, you asked me the exact wrong question at the exact wrong time.
You probably have an option.
It's to do with how the signed distance field blends between the different shapes.
That's a fair decision. So by default it's set to union, but if we were to choose smooth union, all of a sudden these two fellas are treated as one. And again, there are quite a few other options. So it could be replace. Well, it doesn't do much in this case. Intersect, that probably will do better. So I think it's something like, for instance, Cinema has in 3D objects like Boolean, isn't it? It could be.
Yeah. Well, they're different blend modes essentially for procedurals. Constructive solid geometry, as Gloom 909 actually knows what it is called.
10 points. 10 points. 10 points.
909.
We should have some kind of award system that would be applicable for online awarding. Well, thank you, Gloom. Yes, indeed, this is definitely looking like a meta ball. So, but this is not the final thing we are going for. Now we're gonna take all of this system and we're gonna pipe it into a cloner. So we're gonna choose clone to procedurals. Again, the process of this will be quite similar. We need to pipe in this system to the first input, procedural root, and we need to output some kind of a shape. So I'm gonna grab shape 3D, and I'm gonna straight away set it to a rounded box. So now I can take the procedural root and pipe it to procedural root input of the clone to procedurals. Ta-da! Now we are back to a Minecraft, basically. So if we wanted to take this a little bit further, we could, for instance, animate this one going on and off or sliding back and forward, again using those same math modifiers. We could easily add a couple of more outputs. It could be, say, sphere. So we have alternating setup. Yeah, iterate is fine. Yeah, and we can apply some effectors if we choose so. In fact, we can make sure that we don't see the whole procedural thing. We only see the clones. So I think it's going to be more visible if I take out the boxes. So in the procedural meshing, we have an option called visible. So if we slide it off, there we are. This is only clones in procedurals now. Again, we can tweak it further. We can add more of the 3D primitives, or for instance, fractal noise. That could be an option too. Well, for a good measure, since we mentioned it, I'm gonna grab a fractal noise. I'm gonna pump it in here. I'm gonna take those a little bit higher. Stacking order here is important. And I'm gonna offset the fractal noise position Y. And in fact, I think I'm gonna make sure that this is intersecting instead. There we go. So now we see cloners only where it's intersecting. I think we need some more distance off that. There we go. I think I'm just gonna leave it at that for now. Right, what else do we have? Transform array. So for those instances where you need to pipe in some external information to Notch, perhaps you have a very exciting graph to show to your corporate customer. Well, that's probably the best way to go around it. So I'm just gonna make a new layer. I'm just gonna call it array. I'm gonna do what I should have done when I was making a layer. I'm gonna enable deferred rendering, high dynamic range, anti-aliasing, drop in the light, Ctrl-Shift-G, unhook the light from the group set, pipe it to the root, grab a couple of nodes that will come handy now. So let's take that very one. Where is it? There it is, clone to transform array. As you see, this one comes in hashed out red too. Requires extra information, and that is because it requires a source material. So I have this little CSV proxy file. It's basically just data or numeric values separated by commas. So I'm gonna grab that, and now we need something to read this CSV. So in this case, I think the best choice is CSV-table transform array. I'm gonna pipe it to the root, connect it to the cloner, and in the CSV table, I have to make sure to load in the file we have in resources. Done. So now, if I grab a shape 3D, this shape 3D is being outputted in the very numeric values that this CSV gave us. Armin, make bounding box bigger. Yes, sure, I'm on it. God. There we are. So if you need to make a graph, that's probably a good starting point. This definitely could be a chat of its own. I would suppose that there's many applications to this, but I think we can leave it at this, just to mention that it's out there and available. And if there's interest, we might just make a stream all about that if that has traction. So before we move on to this more complex setup, and I'm being cautious with time, we actually are already chatting about for an hour. So I think, man. Exactly. I'm gonna mention rigid bodies just for a sec, and then we move on to this more complex setup, and we're gonna try to hammer it out quite fast. Right, so I am going to make a new layer, call it rigid. This right here could be a course of its own as well, and I'm sure it will be at some point. So to take advantage of rigid bodies, we need a regular cloner. We need a shape 3D to output from it. In this case, I'm gonna make this into boxes, and I'm gonna set it to 3D grid. This is fine. I'm gonna make it smaller though, so smaller in the sense that there's just less space in between the shapes. Great. For this instance, I'm gonna use skylight because we're gonna apply some physics and it's just gonna be all over the place. So anti-aliasing, high dynamic range, deferred rendering, a must. I'm gonna make it a bit brighter, and I'm gonna make it a bit cheaper because skylight is a nice way of lighting things, but it's GPU intensive. So I dropped all the settings quite a bit because all we want to do is preview things. So what I'm gonna do now, I'm gonna grab this cloner, I'm gonna rise it a little bit above, and I'm gonna go to the effectors list and choose rigid body effector. And it will be applied straight to the first input here. So rigid body effector tells Notch that, okay, so these fellows right here, they are to be treated as dynamic objects. Now we don't even need the floor because this emulates floor as well. And we could still apply all the other effectors as we please. It's just they would update dynamically on the restart. So in this case, I have a randomize effector. I'm gonna make sure that it randomizes the scale. I'm gonna hit home, and I'm gonna offset the rotational values. There we are. The most exciting cubes I built today. So again, this can be a conversation of its own. I just felt like it's worthy to mention. This is rather new thing we have in Notch. There's a whole section now corresponding with this, physics. And again, if you guys are interested, I'm sure that we can make a stream about it, and there's tutorials coming about it too as well. Right, so I am hitting save on this file. We spoke of a regular cloner. We spoke of a mesh emitter, mesh cloner, then volume cloner, spline, image, particles, procedurals, and array for those very exciting charts of numeric values. And we touched a tiniest bit on the rigid bodies. Cool. So I'm gonna close this off, and I'm gonna start a new one. So file, new, blank. He is preparing. We will wait. Let's call this cube. Why not? And let's take a look to the video that we've checked in the very beginning. So what's happening here? It's a cloner, but this cloner is being rendered via level sets of fields to procedurals, and from procedurals to cloner, just like we did before. So the only link that we haven't discussed and we're gonna use is level sets. Now, fields on its own is a way to emulate, for instance, smoke simulations. But if we use level sets with fields, we can translate all of that to 3D meshes. And since it's a 3D mesh, we can then pipe it into procedurals, and from procedurals to cloners. Did I forget something, or did I describe something wrong, Ryan?
No, that sounds about right.
All right, cool. Then let's move on. Right, so let's start by adding deferred rendering, high dynamic range, anti-aliasing. Let's add a light fixture. Let's make sure to ungroup it, set it. Let's have a grid for now. It's gonna make things easier to read. Cool, so I'd suppose we could start by adding a... First of all, we can build a field system, and then we can translate that to field level set. Let's do that. So just like particles, fields is quite fast thing, so it has its own root. So I'm dragging in field root, and as you see, it comes in as a quad. And that is because it's only with the information of the width and height. The depth is set to 1. So by default, fields are set to 2D setting. So if I was to grab now a primitive emitter, and let's say add a renderer, so field renderer. Again, color coding here is quite important too. So if you grab the primitive emitter from particles, which is orange, it's very likely, very likely that it's just not gonna work. So when it comes to fields, all is cherry. So if I start rendering now, I see that there's this very nice flat point. And that is because we have a depth of 1. But as soon as we increase that, so let's say I'm just gonna match it up to 256. Now it's in 3D. Yay. Now I think that 256 is quite excessive, so I'm gonna bump all those 3 values to 100 by 100 by 100. And I don't want this to be a coin, I want this to be a sphere. So instead of a circle, I'm gonna choose a sphere. Cool. So even though I really like it, it's quite boring. So I'm gonna refer to my favorite effector, turbulence. Again, it has to be the pink one. And now it starts to do something. Again, just like voxel cone lighting and just like procedurals, it works in a bound box defined by the field root in this case. So this is more or less ready, but this turbulence is not to my liking. So what I can do, I can reduce the velocity amount, and I can bump up the scale of the noise. And if I hit home or reset the playhead, I see that taking effect. Cool. So what I want to do now, I want to take all of this and make it into a 3D mesh, and then from there on, I want to make all of that 3D mesh into a clone system. So let's do exactly that. let's swap the field root node with the field level set. Now I'm gonna leave it as is for now, and I'm just gonna make sure that we have a procedural system that we can pipe this one into. So yet again, I'm gonna go for procedural root. We need some kind of a definition on how should it render. So meshing is a way to go. So procedural meshing. And now we need a node that we haven't used. We need a level set. So we're gonna swap this field root with the field level set root. And we're gonna bring this one in, the level set from generators, from procedurals to procedural system. So then these two can talk. So I'm gonna right click, replace node with fields level set. So now I can grab the level set and input it here to the field source. And as I do, all of a sudden I have a 3D mesh based from that smoke simulation that we built. Now it's not really perfect. We could go to procedural meshing and bump up error tolerance and add some smoothing iterations. In fact, we don't need field render, so I'm just gonna disable that now. And that would get us places, but since this is just a shape that we're gonna pipe to cloner, I'm just gonna leave it as is. I don't really care that very much about smoothing it or fixing the errors. In fact, I don't even think I need it so dense as 256 by 256. So maybe 160 by 160 by 160 gonna work for me. Cool. So let's grab all of this now and let's pipe it to the cloner. So clone to procedurals. Just like we did before, we need a shape to output. So in this case, it's gonna be shape 3D. Is somebody still watching, or you guys are already sleeping? Are we going overboard with time? I am certain that it's like solid 15 to 20 minutes more and we should be good. So I'm gonna change this to a rounded box. And again, these are not talking yet, and that's because we're watching. That's comforting. That's good. All right, so I'm gonna connect these two fellas here.
There's at least 4 of them.
Great, because I thought that I'll have to put on Celine Dion, this famous song, like, oh, no, I'm not gonna try to sing. This will not. Anyways, now we're piping in procedural root to the clone to procedurals. And there we are. These things are talking. However, I really don't want to see the actual procedural meshing. So what I'm gonna do, I'm gonna go for visible and set it to 0. Greatness. So it's not perfect yet. Perhaps we should have a little bit of smoothing and maybe a little bit of error tolerance. And I think it's still super uniform, and that's as boring as it gets. So what we can do, we can add a randomize effector here to the cloner system. And of course it has the position Y offset by default. We don't want that at all. We want them to be in uniform scale and a little bit smaller, for instance. So this is a little bit more interesting. It's just super flat lit, so we can introduce some colors here. So as we spoke before, I'm gonna go for color ramp effector. Mind you, it's spelled in British way. Color ramp.
I mean, I'll have you know that's the correct way.
Yes, it is. Of course it is. Cool, so this node doesn't work on its own. It needs a color ramp. So I'm gonna grab a color ramp. And if, for instance, you find yourself not creative with color picking at a given moment, there is this very nice website called Adobe Color CC. So color.adobe.com. Well, basically it just has a very cool palettes available for you. So for instance, we could just try to copy this. So this setting has 5 iterations. And let's take a look. So it's like from dark blue to the green and to the orange. Right, well, let's just go for that then. Dark blue, a bit of green of sorts, a bit of green should be more pastel, but let's figure that it passes. And then to a little bit more hot orange. Brilliant, but it's all sort of set to the position X setting. So we spoke there's quite a few. So in this case, I think fractal noise is a good friend for us. It's just super fast. So I'm going to reduce the animation rate. So there we go. Now we're getting somewhere. One thing I don't like is the fact that we're hitting some kind of a wall here, as you see. So that's just not fun. I just don't like that. So in procedural meshing, we have these bounds. Now we can restrict it by using a primitive shape. Let's grab a 3D primitive. Let's pipe it in here. I'm gonna, just for the sake of, as you see, as I add it, it just fills it up. So for the sake of explanation, I'm gonna kill off the clone to procedurals, Control-1. And I'm gonna make this procedural meshing visible. So I'm gonna set it back to visible. As you see now, all types of crazy is happening. That is because we're rendering those two together and they don't really talk at all. So I want this one to intersect. So now all this crazy is actually happening inside of the sphere, and that's exactly what I want. I don't really care that it doesn't look correct, because in this case, it's just a proxy. It can be as crazy as it wants.
Yeah, this stuff is just errors in the sign distance field. So if you want to get rid of that, if you actually want that mesh to look smooth, you can increase the error tolerance or increase the resolution of the mesh, and you'll get it to look a lot nicer. Well,
yeah, in fact, maybe it's worth it than just to show. So if I come back here to the procedural meshing, make it visible, bump up the resolution to something more decent, 256, 256, maybe a bit smoother, maybe a bit more tolerance. As you see, it's becoming better. So if I was to, 256 here as well. If I would carry on increasing those, it would just get better and better. Actually, now it's quite decent. So I just don't want to kill GPU for no reason. And again, since we don't really render this to screen, I don't see a reason to really go for a high resolution here. So I am going to bump it down. I'm going to leave it at crazy. I am certain if one of our owners or manager sees this, they might be not happy about it. But they would probably voice this happiness in comments if they're actually watching this.
Yeah, I wouldn't ask who Gloom 909 is.
I wouldn't dare to ask myself. Right, so this is a little bit more interesting. One issue we have is super black. So, I mean, super dark in the background. super dark. I am going to add a light scattering beam to fill in the background. So with the Control-R for root, so Control-R to connect it, I am enabling it. I'm going to enable depth test as well. And I'm going to reduce the brightness. In fact, I want this quite smaller. It could stay in a sphere, and it could be blue and quite dark. There we go. And we are working still with the primitive emitter of the field system that is set to sphere. What would happen if we would set it to torus, for instance? We have a almighty donut. Great, that's actually much more interesting shape than a sphere, because now I have an issue with seeing this little dot there in the middle. I can hide it. I can hide it by just grabbing a shape 3D, setting it to the very same rounded box, making it smaller, very small. And let's call it an intentional design decision to have it there. It's actually just hiding things. And since we're on Cloner, we might as well grab a clone to mesh and pipe this shape 3D as a object that another set of little boxes is cloned on. So of course, let's just go for spread over surface. Brilliant. We don't need many of those here. There's 100. So let's like set to 5. In fact, we can then grab the same color ramp effector and feed it there so that it would match it. Great. So the same randomize probably could be applicable here too. Why not? No, doesn't make much justice here. So we're gonna add a new one. So there we are, randomize effector, pipe it in here. Too harsh, too much. Default is just too big, too big. There we are. All right, one more thing we can do to address the way it behaves or the way it spawns, we can pipe in a fractal noise here, just like we did when we spoke about procedurals. So I'm gonna type in fractal noise and I'm gonna pipe it into the procedural root. And as I do, I see it being rendered already. Greatness, but I want it to be rendered inside of the bounds of this 3D primitive, this sphere we had. So I'm just gonna make sure that it hits the bounds. I'm gonna increase the distance offset, maybe add a bit more of gain, and I'm gonna change these two guys places. And as you see now, the fractal noise is rendered before 3D. So it's first level sets, then fractal noise, then 3D primitive. Now the only problem is this fractal noise is static, but we could take a continuous modifier and affect this position Y. So continuous, fractal noise, position Y. I'm certain that it's going to be super fast. I'm just going to make it slower. Well, there we are. All right, so this is a little bit more interesting setting. We could have a little bit more iterations. Right. Can we have more? 7 is probably a little bit overkill. This works. Cool. So, can we achieve even more randomness or fun to this? Of course we can. Clone scale or... So we could set a math modifier here, so it would seem like it's breeding the distance to clone size scale. I think I'm just gonna go ahead and do that. So math, distance to clone. Yeah. So this is super huge. Again, I'm gonna reduce the scale and the speed.
Somebody wants us to try and use curl noise. I think we should indulge.
Well, then appropriate question is, where do we curl the noise? Do we curl the noise in fields, or probably fields? Why not?
Let's do it with the fields.
Curl noise indeed. I'm gonna take out turbulence. Seems that it's not a hip choice anymore, so let's just go for curl noise then. Let's reduce the simulation speed and maybe the size a little bit too. So voila, this is curl noising. I'm gonna bump it up just so we see that it's happening. In fact, one thing more. Now let's just talk a bit about the post effects. Or before we do that, maybe I'll just make a bit more sense out of this whole thing. So I'm just gonna make sure that it looks more decent as a setup. Right, this is correct. We are not using this, neither that. So we started with the fields, then we went for procedurals. This very procedural has a continuous modifier, that's fine. And this is the last one being rendered. Awesome. So then this whole thing is being sent to a clone to procedurals, and it has a couple of effectors. Effectors are shared, that's why we have this crazy line here. This one goes here. Let's keep the light scattering being next to the lighting system. And I was talking about posts, but we could easily just add one more light just for the kicks of it. So I'm adding a regular light. I'm gonna set it a little bit above. It's too harsh, and it should have some shadows, and then voxel cone lighting could be just a little bit reduced. All right, cool. This is getting somewhere. This is much more fun. Well, post effects. There is this node that is responsible for outlining 3D objects. I'm gonna apply that. Let's see. That looks quite okay. I'm gonna give it a color, and I'm gonna add one and only the best post effect in the world. You guessed it, glow. And as expected, it just kills off everything in the scene. In fact, I want the glow only on the 3D object outline. So what I can do, I can use a render layer to define that these two fellas right here, they are working separately and they're doing their thing. Their thing in this case is being glowy. All right, there we are. In fact, this light is still quite harsh. We could grab a copy of Shape 3D, pull it in. We don't have to change much of it, perhaps make it a tiniest bit bigger, and make sure that they are iterative. They are. And what if we grab a material and make it a bit emissive, for instance, for one of them? Ah, that's just another level of crazy. In fact, I'm gonna go to the render layer. I'm just gonna reduce the very layer alpha, because I can just tweak both of them by reducing the render layer alpha. There we go. That wasn't the best decision ever, but yeah, let's skip that. Cool. I think this is quite close to what we had here, no? Oh, there's camera shake, or not shake, but the camera pivot. So let's just do that and let's call it a day. So now we're in an orb view. So on the keyboard, it would be number 5. And if we want to have a camera, let's add that. I'm typing in camera. Ctrl R to connect it to the root. As you see, it comes into the very center of the graph. So what I want to do, I want to have this camera looking straight from where I'm looking at it now. So right click, camera options, set to current view. These green lines indicate the camera jumped exactly where I was standing at. So if I pan out, that's where it is. And if I hit 0, it's looking to that specific position that I told it to look at. Brilliant. So I am not a big fan of keyframing. So instead of keyframing things, I'm just gonna put a null. I'm going to leave it in the center of the scene, where is this whole shape, and I'm going to pipe it in before camera. So root, null, which is in the center, and then camera, which is already offset. So basically, then if I would turn that null, it would turn the very camera too. So we just make a little gimbal for ourselves. So geometry null, connected to the root, yes indeed. And then I'm going to unhook, Control Shift the camera from the root, and pipe it via null. So now I have this null controlling the pivot. It's just a little gimbal. So I can take a continuous modifier, set it here, and use it for instance for rotation heading. You're laughing. Please do share. What is so funny?
Well, I said that we were old ages ago, and now everyone's talking about how young and old we both are.
Oh, Lord. And the idea was to talk about Notch. Fine. I'm just going to ignore this. Fair enough. So this is happening. Great. We can have another continuous modifier affecting the, say, another pivot. So perhaps the rotation bank. Greatness. Well, ta-da, here we are. This is it. Not necessarily exactly what's happening in the sample. In fact, what I did there, I applied some more effectors. So plane effector went to the effector setting, and it was quite small with its fall off. It didn't have any change to its positionals, but it had change to its scales. I just make sure that one side of it is just constantly small. So finishing touch here would be to go for color grading. So there is this very nice source of LUTs, of color grading LUTs, is Grayscale Gorilla LUTs. I'm advocating this in every single sort of social endeavor I have when talking about Notch. Probably best 99 bucks I've ever spent. But if you're not willing to invest, there's plenty LUTs available for free. So if you just Google LUTs, you will find quite a bit. So if I go now to assets, LUTs, Grayscale Gorilla, raw, specialty, cube, because that's the very iteration we support, the .cube. I'm gonna mark them all, bring them to the resources, wait a little bit while Notch is done with them. There we are. Drag the first one available for me, connect it to the root. And now in that very node, I can just cycle through different LUTs from the resource panel here. So this is very biased choice. I think this sort of works. The painterly. Cool. Yeah, I think we're pretty much done. So if there is, the default is way too high. Isn't that always the case? Like more is more?
On the film grading.
Oh, Mr. Gloom, you have such a specific outlook to design. Fine. You know what I'm going to do? I'm going to set it to halfway, and then I'm going to grab a copy of it, and I'm going to connect it to the root. Everybody's happy. You have it halfway, and I have it too. Cool. Is there any questions about what we discussed so far? Or maybe something wasn't addressed? I would love to hear you guys out. And maybe we should do something more on the screen. Otherwise, I think we're gonna call it quits pretty soon, because we already keep you bothered for 1.5 hours, which is more, like 5 times more than the attention span of any human being when it comes to software.
Yeah, kudos to all of you for paying attention.
Yeah, thank you. Thank you so very much for sticking around to the bitter end. Great stream. Thank you, Joey.
You can
appreciate
repeat
it.
as many questions as you like.
Yeah, absolutely, absolutely.
Because I'm not the greatest at reading and speaking.
Well, thank you very much, Ryan, for assisting us today, for moderating the chat. That's great. And thank you, Gloom. Who might be Gloom, I wonder. Thank you, Gloom, for assisting us too.
Got a gloomy outlook.
Actually, Gloom is the most up-chair person I know. That's like such a controversy of name versus a person.
He's gone for the oxymoron approach to naming conventions.
Well, while questions are rolling in, if there's any, I'm going to mention that it's not wise to leave a lot of unused resources in the resource panel. So if you click right-click and go for remove unused resources, that is just a good way to make sure that you're not carrying extra information that is just not needed.
Oh no.
Oh, Greg.
Gloom will never come back again.
No, he will. He will because he's Gloom. He's Gloom enough.
Magic the Gathering card in the 90s naming convention.
All right, makes sense. I'm hitting save, and I'm gonna call this Cuba stream. I think I'm gonna spend a minute after the stream is finished sort of just making sure that this looks a little bit more appropriate, like it's not scattered around as is now, so it's easier to read. And the first thing I'm gonna do, I'm gonna upload this to the user group. And by the way, shout out to Notch user group in Facebook. If you are not on it yet, please join. It's a great place where a lot of great people are sharing their stuff, asking questions and getting the answers really fast from a lot of advanced users. So I'm gonna post it there, and once the recording is edited and ready, without our jokes and mishaps, it's gonna be attached to it as well. So yeah, is there any questions? If not, I think we call it a day. We call it a victory, and yeah, we wrap up that episode 1.
Yeah, go to the Notch Facebook group. It's a really good place for getting questions answered. The chat's going a little bit too fast for me to type out answers, but you can get lots of a lot of your questions if you just post them there. There's a whole community of people.
Yeah, and
want to respond.
If you find something going too fast, or you are left wondering about things for, say, procedurals or particles, I would encourage you to check out Notch Academy. That's very good 101. It's good foundation. So if you've seen it, probably majority of things made sense, or everything made sense. If you got stuck on something, well, do check it out if you haven't yet. That's just a good place to check things.
Will there be any live streams or tutorials on triggering / modifiers at all? Probably.
Yeah, sure.
We can line that up.
The idea is that all of this is community driven, so if that's what you are interested in, I don't see why wouldn't this be a topic for a stream.
We can do a poll and see what the next topic will be.
All right, this is getting to a place where it's know-how to be described as a tutorial. So I think I'm gonna thank you guys. Thank you for sticking around and watching this, and I think we're done for today. So thank you very much, and I'll be back with the files. Thank you, Ryan.
Bye.
Goodbye, guys. Thank you.